My name is Kelly Paffel, and I want to talk about steam trap sizing. This is part two of a two-part series, and I just want to do an overview. I'm the technical manager for Invino Engineering LLC. We're located in Florida, and we are a domestic international firm specifically for engineering and steam and condensate systems. Going to a sizing example, and when we come up with a sizing example, one of the things we need to do is come up with a sizing factor. All steam trap manufacturers will have a sizing factor for their condensate capacity charts. Example, inverted buckets are 3 to 1. What does that mean? If my condensate capacity is 200 pounds per hour, then I take 3 times 200, or 600 pounds per hour. So I want to select a steam trap for 600 pounds per hour in the capacity chart. Flow and thermostatics are 2 to 1 sizing factor. Thermostatic is 3 to 1 sizing factor, and thermodynamic is 3 to 1 sizing factor. And we talked about part one is determine the steam trap discharge pressure or condensate return line pressure. So the thing with this here is that we need to understand P4 and P3 in this system, so we get our differential pressure. And differential pressure is, really critical when we're coming up and making the correct selection of the steam trap. Evaluate the condensate flow condition for the steam trap operation. We have two types of steam traps. No matter what steam trap is manufactured, there's two types. One is continuous flow, and the other one's on-off operation. So when I come up and say, I have a heat exchanger, it's got a modulating valve, that's going to be a continuous flow to the process. I might want to go with a continuous flow type steam trap or operational design. The other operational design is on-off. The other thing is to determine the orifice inside the steam trap. And one of the things we need to know the maximum steam pressure or body rating of that steam trap. So at P1 we need to know here what is the maximum pressure that can come down or steam pressure can be applied to the system. So if the safety valve is set for 150 psi, the orifice inside the steam trap has to be rated for 150 psi. The next thing is that also comes up with the body rating. So the body rating has to be rated for 150 psi at 366 degrees because we're underneath the code. The power piping code, or depending on what country, there are codes that govern steam and condensate piping. The operating pressure. The operating pressure, an example would be 75 psi. And then we need to know the inlet to the steam trap and the minimum differential pressure. And on part one, we talked about how to come up with the pressure drop across the control valve, how to come with the pressure drop through the heat transfer. So we come up with P4 and P5, which is outlined in this presentation. So therefore, we select a maximum pressure rating, which we already said that, the maximum pressure rating would be, 150 psi, 366 degrees. And then we come up with P1 minus P2, which on our example, we came up with a differential pressure of 55 psi. The condensate capacity sizing factor, we'll just take 200 pounds per hour. We put a sizing factor to that, which is 600 pounds per hour. So on this side right here, as you can see here, is the maximum orifice pressure rating. So we must find something that's 150 psi rated or higher. So this is the differential pressure. So we said the differential pressure is 50 psi. So we come down this column 50 psi till we find something 600 pounds per hour. We come to the first one, it's 1400 pounds per hour here. Well, 1400 pounds per hour, if I go over to the left-hand side, the orifice is only rated at 50 psi. We said we had to have the orifice rated for the maximum pressure, which is 150 psi. So if we come down 150 psi, 50 psi differential, and then the capacity is only 410 pounds per hour. So we have to come down to the next model, steam trap, with 150 psi, and the capacity is now 990 pounds per hour. So therefore, we come up with the correct steam trap selection. Now, back pressure in the steam system, the back pressure is always going to be there in the steam system, which means that, the thing with the steam pressure, the back pressure, it can be intentionally designed or because of the installation. A high percentage of the steam trap applications, they are going to be pressure on the discharge side of the steam trap. That is given. One of the biggest problems we have in the steam trap sizing is we don't know the back pressure against the steam trap. And probably 95% of the condensate systems, there is back pressure. Now, back pressure became unintentional or deliberately produced by the design of the system, because today we are looking at implementing pressurized return systems to increase the steam thermal cycle efficiency, which means there is going to be intentional back pressure onto the system. The other thing is that if we take a rise here, up, after the steam trap, there's going to, for a rise in the piping system, there's going to be back pressure. And the rule of thumb is a half a psi for every foot rise in pressure. So therefore, there is going to be back pressure onto the steam trap or down here at P4. The other factor is that undersized condensate lines, which I already mentioned, is a big factor today in steam and condensate systems. So therefore, 95% of the time, we're going to have back pressure onto the system. Now, as I said before, this is condensate line pressure intentional. That today we design condensate systems to be pressurized so we can bring the condensate back to the boiler plant operation under pressure, increasing the steam thermal cycle efficiency. It's really critical that you have pressure gauges on your condensate system so you understand, what that pressure in the condensate system is going to be. Another example here is a drip leg steam trap, which is a common steam trap out there in operation. P1's 150 psi. We have 25 psi back pressure, 2 psi, for the rise in the pipe, condensate pipe, because it's 10 feet rise. So we really have 30 psi differential. My flow is 120 pounds per hour. So I go and sizing factor is 3. So, I'm going to use a thermostatic design steam trap. So 3 times my capacity, I have to pass 360 pounds per hour condensate. My differential pressure is 125 psi. So if I come down to my sizing chart, the maximum pressure rating we said was 150 psi. So all these steam traps here have a maximum pressure of 450 psi, so it's not as prevalent in the mechanical design steam traps. So I come here to 125 psi differential, find something greater than 360 pounds per hour. I see I have a steam trap here, 838 pounds per hour. So it'd be a model 452. And then I made my selection of my steam trap. These are the informational charts. In our website, please visit at www.invinoeng.com, and we have a tremendous amount of information for your review. Thank you. Have a great day.